Welcome to Math Master. This is Saritha. Today our topic is algebra. So we will discuss all these subtopics in this chapter. Okay. So what are our subtopics? First topic is introduction and basic definitions of algebra, and the second topic is factorization of algebraic expressions, and third topic is polynomials, and the fourth topic is linear equations in one as well as two variables, and the fifth topic is powers and exponents, and the sixth topic is modulus of a real number, and the seventh topic is special products. So in this video we will discuss introduction and the basic definitions of algebra. Okay, as I said, for any chapter the basic definitions are very important. By depending upon the definitions only, we are using the terms, different types of words. We say constant, we are saying sometimes, variable we are saying sometimes, numerical expressions. So there are different types of words. So for that, if we know the exact meaning, then only we use it in the different situations. So that is why we should know all the basic definitions first before entering into any chapter. Okay, so our first definition is constant. Very often we use the word constant. So what does it mean? Constant is nothing but it is a fixed quantity. Fixed quantity means it doesn't vary. Always, whenever you take that value, doesn't change anywhere. See, you take one number. So I am considering 5 number. Okay. So does the value of 5 changes depending upon the situation? No, right? See, 5 value doesn't change. Yes, I have considered 5 here. Itself is a fixed quantity. It doesn't change its value. So you take this 5 in other situation. There also that is fixed. It doesn't change. So that is why we call this as a constant. Okay. So that fixed quantity or a fixed number, we call it as a constant. So our second definition is variable. In this chapter, we use these terms very often. So that is why we should thorough what exact it means. So variable. Variable is nothing but which that value depends on the situation. Means the value changes always. Means it is not fixed. See, you take one alphabet. So this is a x. So if I take this x value as any number, so I considered this x value as a 3. Okay. But some other one, they consider this x value as a 5. Okay. So because he needs x is equal to 5, I need x is equal to 3. So depending upon the situation, this value is changing. That is why we call this alphabet as a variable. So we always represent variable with a different alphabets, small letter alphabets. Okay. X, suppose X, Y, Z, or small a, small b, small c, and so on. So you can represent this variable with small lowercase letters, small letters. Okay. And the next term is, next definition is term. In algebra, we always use the word term. So what do you mean by a term? Term is nothing but, as we have discussed what is a constant and what is a variable, this term is nothing but it can be either a constant or a variable or a product of constant and variable. See, I have considered 5 as a constant. Yes, this itself called as a term. Okay, or it can be variable. Yes, I have taken x as a variable. So yes, this is also a term or a product of constant and variable. See, if you take a product of these two, constant and variable, 5x, So this itself we call it as a term. Okay. So it can be constant or a variable or a product of constant and variable. So if the structure of the term is like this, then we call that as a term. Okay. So this can be 5x, 7x, y square. It need not be only single variable. We can have any number of variable, but that must contain product of constant or variable or different types of variables. So we should take a product of all these. Okay. Then only we call it as a term. Okay. Is it clear? Next definition. Our next definition is numerical term. So the name itself telling us numerical term. So we have, if we consider only constants, means some 5, 6, 10, like that. If you consider only constant values, then we call that as a numerical term. Our next definition is algebraic term. What is an algebraic term? If first it should be a term. Okay. So the term which contains at least one variable. See, in the previous definition, we have considered all are constants only, not even a single variable. But in the case of algebraic term, it must contains at least one variable. Means it may have more than one variable also, but it must contain one variable. Okay. See, 7x. Okay. So x is a variable, right? Yes, one constant, product of constant and one variable. Yes, it is an algebraic term. Or C, 5x y square. Yes, it has more than one variables and product of one constant and more than one variables. Yes, this we call it as an algebraic term. So you may have any number of variables, but it should have at least one variable. Then we call that term as a algebraic term. Okay. And our next definition is coefficient. What is coefficient? See, you take one example, 7x square y. Okay. So this is our term. Okay. This is an algebraic term. At least one variable. So when we say this is a coefficient of others, see, what is the coefficient of 7? Coefficient of 7. Coefficient of 7. What is the coefficient of 7? So in this term, except 7, we call the remaining variables, we call that as a coefficient, which is nothing but x square y. So what is a coefficient? What is the coefficient of x square? Which is nothing but except x square. You write the remaining part, which is nothing but 7y. So it is a coefficient of x square. So once it has a coefficient in variables also. So always we consider only constant term as a coefficient. But there are two types of coefficients. One is numerical coefficient and other is literal coefficient. So numerical coefficient is nothing but the constant value, whatever may be the constant value, so that we consider as a numerical coefficient. And if the coefficient is in the variables, then we call that as a literal coefficient. See, so coefficient of 7 we have taken x square y. So this is what? This is a literal coefficient. Literal coefficient. If he asks what is the coefficient of x square y, then we say it is 7. So now it is only a number, okay, a constant value. That is why we call this as a numerical coefficient. Okay, so these are the two types of coefficients. Next we'll see what is an expression. What is an expression? Expression is nothing but it is either a term. So it may be a term or combination of terms by adding plus or minus in between. Okay, combination of terms. Combination of terms by joining those two terms by plus or minus. See, it may be a term. Expression is nothing but it may be a term. See, yes, 5x I am considering. Yes, it is a term. It is also an expression, isn't it? According to the definition. And combination of your terms by joining plus or minus. See, I am considering 5x plus 3y. This is one term. This is one term. These two terms are joined by plus symbol. Okay. So this we call it as an expression. Okay. So it can be minus also. It can be joined by minus also. 3x minus 5x minus 3y. So it is also an expression. Okay. Or you can have one more example. Even a single constant. So I am considering 7 as a This is also an expression because in the definition itself he is telling us it can be either a term. Term is nothing but it can be a constant or a variable or a product of constant and variable, right? So that is why even you take a single constant also we can call it as an expression. Okay. And it is a fixed quantity. So we call this as a numerical expression. It is a fixed quantity. So it is a numerical number. That is why we call this as a numerical expression. And we'll see what is an algebraic expression. Our next definition is algebraic expression. Algebraic expression. It is nothing but an expression. It must be an expression which contain at least one algebraic term. Means at least one variable should be present. Then we call one that is a algebraic term. So if the expression contains at least one algebraic term, then we call that expression as a algebraic expression. See, 3 plus root 2. Is it an expression or not? Yes, it is a term. It is a term. And these two terms are combined by plus. Yes, it is an expression. But if these are fixed numbers, we call this as a numerical expression. Isn't it? So, if we add one variable, product of one constant and variable to this numerical expression, what it becomes? It is an algebraic expression because it it contains at least one algebraic term, isn't it? So this is an algebraic term. So this total expression contains at least one algebraic term. Then we call this entire expression as a algebraic expression. Okay, did you understand? Now tell me whether 5 plus root 3 x square plus yx, is it an algebraic expression? Yes, it is an algebraic expression. See, what I said according to the definition, it should contain at least one algebraic term. So this is one algebraic term. This is one algebraic term. That is why we call this as a algebraic expression. Okay. Our next definition is like terms. Like terms. What are like terms? You take two terms. When we say those two terms are like terms, so they should have one common thing, right? Then only we say they are like terms. So what is that common thing? The common thing is nothing but a variable. So the two terms, if the two terms have same literal coefficient, so we have seen if the coefficient is variable, then we call that as a literal coefficient. If the two terms have same literal coefficients, see 7x, 8x. Yes, it is a literal coefficient. It is a literal coefficient. Okay. So these two terms have same literal coefficient. They just differ by a constant coefficient. That is numerical coefficient. Yes. That is why we call these two terms as a liked terms. Okay. So you tell me whether 7x, 8xy are these two or like terms? No, right? Because in this literal coefficient is x. In this literal coefficient is xy. So they are not like a term. They don't have same literal coefficient. That is why we don't call them as a like terms. Okay? They are unlike terms. Okay? So similarly, you can identify what are the like terms and what are unlike terms. If they have same literal coefficients, then we call them as a like terms. If they don't have same literal coefficient, then we call them as a unlike terms. Okay. Thank you.